Math 2414, Trigonometric Integrals, Integrating a Product of Secants and or Tangents, Part 4. This will be the last video for this type, and then we'll just do one, maybe two more, showing some integrals that do not fit nicely into product of sines or cosines, or product of secants and tangents. Because I'll be honest with you, when it comes to integrating trig functions, I don't want to say there's no way, but it would be very difficult and very cumbersome to categorize every possible scenario. So instead of saying, well, if it looks like this, I do that, and if it looks like that, I do this, you just have some strategies at hand, and you jump in and hope for the best. One thing I did want to point out is that there are integrals of products of secants and tangents that don't fit nicely into the techniques that used to live here on the previous video, namely if the power of secant is even or if the power of tangent is odd. But what if neither of those is true? What if the power of tangent is even and the power of secant is odd? Then we really can't do any of those techniques. If we try to say u equals tangent, then its derivative would be secant squared. We would pull off two secants and have an unwanted secant left with an odd power. If we said u equals secant, then du would be tangent secant. We would pull off a tangent and a secant. This would be an odd power tangent, and it would be unwanted. Remember, when you're making these substitutions, you want the unwanted trig functions to have an even power, to use a Pythagorean identity to change them to the wanted trig functions. So what do we do here? Well, I'll be honest, I set up this problem at random between videos, and I kind of plotted a little way through it until I could see that there was a path to the end. But I did not complete its path, so what you're about to witness is almost an impromptu solution being worked out, but I do kind of know that it's going to work, and that's what I wanted to do. I wanted to make sure that there was a path to the end and not just have this crash and burn. But I want to kind of clarify and state my thoughts as I'm going through this problem. The first thing I'm thinking is this doesn't fit either of the criteria for the power of tangent to be odd or the power of secant to be even. So I'm just going to try something and hope that it works. By try something, I mean let's try a Pythagorean identity. Because this is tangent squared, we can change it to secant squared minus 1. And still have the secant cubed. So at least it's all secants now. And if I distribute the secant cubed and split this into two integrals, I get the integral of secant to the 5th x dx minus the integral of secant cubed x dx. I know this one. We did this in the last video, and it's not uncommon to say, oh, I'll use a prior result to create a new result. So let's go ahead and put a check on this and go to the side and just remind ourselves that from the previous video, the integral of secant cubed x dx was equal to, I'm going to put 1/2 in front instead of 2 underneath, secant x tangent x plus natural log absolute value of secant x plus tangent x, and then plus a constant. And I'll be honest, I would not have remembered that off the top of my head. I'm going to write it over here if I had not just done the video. And you know, I'm okay with that because all throughout my career as a math student, as a mathematician, and a math professor, I've always said to myself, if I don't remember the answer, do I remember how to get there? And at that point, I stopped trying to memorize everything. Because all I have to do is remember the path there and take that path. All right, so this guy is done. So when the time's right, we'll grab that answer and stick it in here. So now our focal point is how do we do the integral of secant to the 5th? Well, having just done this one, I wonder if I can take the same approach. Remember what happened here? We did an integration by parts. After that, we did a Pythagorean identity and ended up getting the same integral twice and solving for it. So I'm wondering if that was just special to this or if that will work for other odd powers of secant as well. So we're going to try doing the same thing. Spoiler alert, I'm pretty sure it's going to work, but I wanted to figure that out before. If we're going to try integration by parts on this guy, because that's what we did for the odd power, then let's think about how we would split this into two powers of secant, one of which is integrable and the other one is, well, they're all differentiable, but one of which is easily integrable. So what powers of secant can I integrate? I can integrate secant That's natural log of blah, 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 but I don't want to cram that in my next integral. I can integrate secant squared, that's just tangent, derivative of tangent and secant squared. I can integrate secant cubed, but remember, whatever we integrate is going to wind up inside the next integral, and I really don't want to put that inside of there. Can we integrate secant to the fourth? Well, we might be able to, but knowing that I can integrate secant squared easily, I think I'm going to make that my dv. So let's try that. Let's try integration by parts where u is equal to secant cubed of x and dv is equal to secant squared of x dx. Integrating the dv will just give us tangent of x, so that's not too bad. Excuse me. But what is du? Well, we have to use the power rule and the chain rule. Power rule, bring down the power, keep the base the same, so 3 secant squared x. Chain rule says times the derivative of the inside. The inside of the power is secant of x, and its derivative is secant x tangent x. So it's getting a little crowded here. But I can clean that up a little bit because I've got a secant squared times a secant, so I get 3 secant cubed x tangent x dx. All right, so let's set up integration by parts and cross our fingers. All right, so u times v, so secant cubed times tangent of x, minus the integral of v du. Here's v, here's du, and when I put them together, I'll get a 3 secant cubed tangent squared dx, yes. 3 secant cubed tangent squared dx. Let me make sure that's right. 3 secant cubed tangent squared dx. All right. Well, that looks familiar. Well, first off, I left the x off the secant cubed. But is that not the very integral that we're trying to solve for? And I'll be honest, at this point between videos, I changed the tangent to secant squared minus 1. Got me a secant to the 5th and said, hey, I'll play the game of the secant to the 5th. But literally, right now, you are seeing this live and you're seeing this discovery moment as it happens. I didn't realize between videos that I accidentally ran across the integral that I started with. So I think that's going to help us finish this. Okay, so let's remember where we were. We were working out this integral separately, and we got that. So this being equal to this can go there. So let's set up a therefore and see if we can stick a fork in this. Integral of tangent squared x, secant cubed x, I'm rewriting the problem from the beginning, is equal to the integral of secant to the 5th x, but that's equal to all this, is equal to secant cubed x tangent x minus, I'm going to pull the 3 out, integral, and I'm going to put the tangent squared first. 3 tangent squared, 3 integral tangent squared secant cubed x dx. So this was there, then minus this integral, but we already know the answer to this integral. It was, that integral's answer was 1/2 secant x tangent x plus natural log absolute value secant x plus tangent x. Close all that. And I think I can finish this in one move now. I'm going to kind of do some scribble math here. If you were turning this in for a grade, I would not do this. You know what? I won't. I should model it. I'm going to solve for this integral because that's what I want. By adding 3 of them, I will just write that. Plus 3 integral of all that. And that will give me 4 of these integrals. So 4 integral of tangent squared x secant cubed x dx is equal to this guy, secant cubed x tangent x. That got moved over, minus 1/2 that. I think I'm going to distribute the minus 1/2. I see no need to keep this giant parentheses here. So minus 1/2 secant x tangent x minus 1/2 natural log absolute value of secant x plus tangent x. I'll stick a plus c in a minute. but I need to take care of the 1/4. Multiplying everything by 1/4 will take care of that. So 1/4 of u, 1/4 of u, 1/4 of 1/2 is 1/8. 1/4 of 1/2 is 1/8, and now is a good time to put the plus c. I could have put it before multiplying by 1/4, but 1/4 of the constant is just a different constant. And well, that actually ended up a lot better than I expected. Because again, between videos, I did not finish this problem. I just pushed it far enough until I saw a path towards the end. But during this, I saw a better path towards the end by saying, hey, you match you. Let's take advantage of that. So, yeah, what can I say? I can't teach you how to do every trig integral in a finite number of videos. Well, in a reasonably finite number of videos. I can only demonstrate and give you some suggestions on what might work, and if something doesn't work, just try something else. I do want to do at least one or more 2 videos just showing some other types of trig integrals that don't fall under some nice category.